Right, hello. I would like to talk about a project that we've been working on at Embecosm for producing a new debug server that is geared towards debugging deeply embedded targets. Now, for those that don't know how debuggers work internally, when LLDB and GDB want to connect to targets, they use something called remote serial protocol. It's the text in the middle of the slide between LLDB and the server. It encapsulates all the sorts of things that a target might want to, the kind of things a debugger wants to do, such as reading and writing registers, reading and writing memory, starting processes, stepping, continuing, etc. Now, usually these sorts of things are geared towards a particular operating system or like operating system class. We have written one that aims to be good and generic for any deeply embedded target. Now, inside our server, we have abstracted all of the RSP packets to calls that represent the sort of things I described earlier, reading, writing registers, the same with memory, stepping, continuing. We support multiple multi-core application or multi-core systems, and it uses a plugin architecture whereby for any target you implement the small interface that's written on the slide here and launch our server and it's good to go. We use this internally for simulated targets, so things written in Verilog that have been run through Verilator, and also for talking to real hardware over JTAG. Now, this design allows us to do more interesting things because once we have a nice clean interface, we can compose targets in different ways. So one thing that we have done is built a target that runs two targets at once and compares the result. So this is useful when you are, say, have a model of what your architecture should look like, and you are implementing it, and you want to check that what you are building, especially pre-tape out, actually behaves like your system should. And the way that we have modeled this is that if the targets disagree on what something should, on side effects that have happened. So if one writes one value to a register and the other writes a different value, we treat that as a trap and return control to the user, at which point you can investigate what has gone on. So for example here, you see for a RISC-V target, you step a couple of times. In this case, X31 in one of the targets has written the value 4, in the other it has written 5, and we represent this as SIG-sys, return control to the user, and if we ask for the set of registers, we see the two values that are different. One other thing that we're also looking at is whether you can debug more complex system on chips, whereby you expose multiple debug sessions so that you can do things like set breakpoints on one, start the entire system going, and when that breakpoint is hit on one system, we bring the entire, on one core, you bring the entire system to a halt. We're presenting a poster about this later, so if you're interested in debugging deeply embedded systems, please come and talk to me.
Thank you, Simon.